Hello, Martians. Hang on. That's better. Hello, Martians, and welcome to the 10th annual Mars Rover Design Team Banquet. This is an opportunity to celebrate all the hard work you put in this year, reflect on past years with alumni, and say goodbye to team members who are graduating or moving on. This being the 10th annual banquet, your executive board has asked me to say a few words about the history of the team and its beginnings. Now, in order to do that, we have to go back, way back, all the way to the beginning. In 2012, a handful of students at Missouri S&T decided they wanted to build rovers. None of us had ever built a rover before, and very few of us had any experience in robotics and minimal experience building hardware. But we had the dream, and we didn't know better. So we got together, started organizing ourselves, and putting together the team. We recruited our faculty advisor, Dr. Melanie Moormile, started to make some key connections, recruit a team, and apply to be the 13th design team in the Student Design and Experiential Learning Center, a necessary step to give us the tools needed to bring these rovers to life. Ultimately, we organized ourselves, and on January 11th, 2012, we signed our constitution and became an organization. From there, the work began on our first rover. Now, the rest of you there, you can say it with me. The name of our first rover was Steve. No, not Acres. Before there was Acres, there was Steve, a Frankenstein little RC car that sole purpose was to zip around at public events to draw some attention to ourselves. No, the work on our first real rover, Acres, began the next year, leading into the competition of 2013 at the University Rover Challenge. We got ourselves together, we got organized, we made t-shirts, we set out our plan for the year. And we had it all. We raised funds, we designed structures, hardwares, mechatronics, software, electronics, space stations, batteries, science experiments. We began to put together the pieces until we had a beautiful rover, Acres, named after Colonel Tom Acres, a Missouri S&T alumni, colonel in the Air Force, and former mathematics professor at the university. We took this glorious beast and we went out to the deserts of Hanksville, Utah to compete. And this photo is completely staged. This rover did not drive more than 2 meters in competition. And the results, well, we took last place. Even though we took last place, we made it to competition, which many teams didn't even do. And this provided us the opportunity to learn from this failure. And functionally, it was a failure. But that's where engineering and design really thrive. Failing, rebuilding, and learning from those mistakes. And so, we went back to the drawing board, literally. We had understood that we needed to take a complex problem and break it down into its constituent pieces, but we had to reintegrate it into something that worked. And so we began to adopt some systems engineering principles. We'd recognized that the first ever rover reveal, where we revealed Acres, had been a key driver in us getting together something actually physically to build. So we thought we needed more of those. We adopted reviews, PDRs and CDRs with external folks to take a look at our rover to really motivate us to get the work done at a faster rate. We also incorporated specific phases, things like adding an entire integration, testing, and operations phase, which we'd done mostly on the way to the competition, even in between competition events. All this accumulated in our 2014 competition year. We'd rebuilt everything from the ground up. Custom designs, custom fabrication, hours and hours of hard work went into our new rover, Phoenix. This rover was light years beyond Acres in every manner, every subsystem rebuilt from the ground up. And the results showed. We ended up taking second place that year in the competition, beating out every other US team. And there, we'd done it. We had gone from just a couple of dreamers in a basement of a cafeteria at Missouri S&T to international champions in one of the most difficult robotics competitions in the world. But that was just the beginning. The team continued on from there, bringing in new members, building new things until finally we had an entire family of rovers, building on what we'd learned from Acres and Phoenix. evolving to a whole new generation of remote exploration platforms. Our rovers Horizon, Zenith, and Griffin. In fact, at this point, I remember at the 5th year banquet, we compared it to NASA's own family of 5 rovers. It started off small with Sojourner, named after Sojourner Truth, that landed on Mars in the 1990s, just driving around a small base station, to the twin rovers, Spirit and Opportunity, that while designed and guaranteed 90 days operations on the surface, went on to work for years, Opportunity clocking in at over 14 years of operations. And then ultimately the 2 car-sized, RTG-powered, laser-wielding rovers currently operating today, Curiosity and Perseverance. And so we had our own mirroring families, and I had been lucky enough to work on 2 of each. But MRDT didn't stop there. No, they continued the innovation, developing new technologies, new platforms, and whole new family of rovers, with Atlas, Valkyrie, Icarus, Aurora, and Prometheus, bringing the total to 10 rovers, doubling NASA's number. But what is it about this team that allows us to produce this suite of rovers, taking them to international competitions, bringing in all kinds of members to the team? What is the secret sauce that makes Mars rover tick? Is it our custom and interesting fabrication methods, our dedication to testing, breaking, and rebuilding, our ability to fundraise, or how we plan out our schedule, iterative design, how we allocate the functions, what sort of ways we procure our items, how we integrate them together, our awesome public relations teams, the analyses and models we use, the logistics that go into organizing the team, recruiting the best talent, or troubleshooting problems when they go wrong? What is the secret element that makes this design team tick? All of these items are important, but I think what's truly at the heart of any successful design team is the human factor, the people that make it up. If you were to invest time into any one of these factors, investing in your people will pay dividends in all these areas. You can teach someone to code, you can teach someone to lathe and mill, but if they have a passion and an attitude for willingness to learn, then everything else just falls into place. And so our alumni have gone on to all kinds of great things. We have alumni working across the US and in all sorts of exciting areas. People building spacecraft at Boeing, doing research at Sandia National Laboratory, working at NavAir, working at the Jet Propulsion Laboratory, working for NASA or SpaceX or Relativity Space. And not only in the space industry, we have alumni in all areas of industry and technology, from cutting-edge medical devices to transportation. But what does the data tell us? Looking back over the past 10 years, we were able to look at a couple metrics. First of all, we can look at team member size. That first year, 2012, still building, establishing the team, and our first competition year in 2013. Active team members across the years, ranging from 20, 30, all the way up to 80 members active in a year. A great resource pool to draw from talent. Also, how many public events did we put on? I broke this up into PR events and outreach education events because their purposes are different. Public relation events are designed to bring in the lifeblood of the team, to provide for the team, to bring in new members, new talent, and also fundraising and support for the team. While outreach and education events are giving back. They're inspiring the next generation, teaching about the type of work that we and NASA does, and really putting back out into the community. To look at this a different way, what about the cumulative events? You can look over the past 10 years and you can see we've carried out over 230 public events, both PR and outreach and education combined. That is an incredible number of opportunities to interact with people and really change the world around you. We also have some data on fundraising. You can see our first year of competition, we raised just under $20,000, and that number just went up and up and up. Some years raising upwards of almost $50,000 for their operating budget. You can also look at that cumulatively. That's almost $350,000 raised by this team over the last 10 years. That is incredible. And this is just dollar-for-dollar donations. This does not include donations in kind, hardware, or the thousands of hours spent by the team designing, building, and running this team. I think what really sums up the pieces of the team, really sums up the heart of the team, boils down to our vision statement. today, tomorrow, forever. Today are those 10 rovers. All the work, all the hours spent designing, fabricating, fundraising, recruiting, all that time and effort and sweat, blood, and tears spent on those rovers is for the specific goal of building an awesome exploration platform to take to one of the most complex international competitions in the world. Tomorrow is our commitment to our team members. That by joining the team, you're being involved in an interactive, interdisciplinary design process from end to end. You're learning lessons and you're building yourself a toolkit and a set of experiences that will equip you to be the innovators and instigators of tomorrow. That investment in the human factor. And finally, the commitment to forever. One of the most unique aspects about Mars Rover Design Team's DNA is that we really look for what is our impact in the future. We want to reach out, we want to inspire the next generation of students to enter STEM fields. We want to develop new technologies to better the world around us and carry us to Mars and beyond. Thinking back over the last 10 years, one word keeps coming to mind, and that's legacy. I'm reminded of a quote by Dr. Robert Zubrin, the founder of the Mars Society. What's left after you go is the good you leave behind. You have to believe in hope. You have to believe in the future. What is the legacy of the Mars Rover Design Team? It's not awards or accolades. It's not the 10 physical rovers. It's not thousands of dollars raised or numbers of people we've brought into meetings. No, I think it's more than that. The team's legacy, I think any legacy, is the impact you have on the people around you. At the end of the day, that's all that really matters. All the people who've been directly impacted from the team as a member or adjacently as a supporter, donator, professor, student, members of our S&T and Rolla community, to all those people who we've impacted through our various other means. A small student who went to an event at Space Week and decided they want to grow up to be an engineer or scientist, or someone who saw something we did online and got inspired to start a team of their own at their university that led them on to their own futures. We can impact the world around us for the better. And if that's true, it really begs the question, what kind of world do you want to live in? And how are we going to make it a reality? With that, I want to thank you for the opportunity to have a small impact on your night here tonight. This team and the people on it mean so much to me. It's changed the course of my life and had impacts in ways I can't even measure. And I hope it has in yours too. With that, good evening, good luck, and don't forget to rove so hard.